Okay, so this is our second video on truth tables and propositional logic, or building truth tables for propositions. What I want to do in this video is I'll keep going, and I want to give you one more example of a more, just to sort of to keep you with the idea of how you do this, which is essentially you have to lay out the truth values for each of the variables, and then you work your way up to the main operator utilizing the operator rules, truth value rules that we establish um, that we established some time ago. And then from there, I want to talk about the difference between how you classify statements based upon that and how you compare statements. So let me move my cursor here over here. Okay. Make sure I got everything together. Okay, so let's give you just one more example here in terms of doing the truth tables. This is a little bit more complicated. Here we're going to go A or B and B therefore A, therefore B. So again, for purposes of keeping it simple, we're only going to use two variables, which means how many lines do we have? 4 lines, right? So let's sort of plug those in. So you got true, true, false, false. And I generally sort of start off. Some people find it easier if they essentially write the table of values. Let me move this. If they write the table of values over here, where they can go A and then B. So if this helps you, feel free to do it like this. We just go true, true, false, false, true, false, true, false. Again, for those of you watching online, I'm sorry that my handwriting's so horrible here. It's sort of hard to write on this tablet thing. Okay, so let me just continue to plug all these in. So there's my B. Right, so let's put our example back here. So B here is true, false, true, false. A is true, true, false, false. B, see, I hope you, no, I'm doing it right. Okay, I thought I made a mistake there. So B is true, false, false. Okay, you'll notice that I've just kept the same system that I established over there. So if it helps you just to write them out in the beginning, you can do it like that. Many of you after a while will be able to just do it. The key again is just to make sure that your A's all look the same, and that your B's all look the same. Because if you screw that up, if you make that mistake, then you're not going to be able to, you're basically unable to do the problem correctly. Okay, so now let's sort of go through here utilizing the rules. Now remember, we want to work to our main operator. So you have to establish what is the main operator. Well, in this case, it's this place right here. It's that conditional statement. Yeah, that conditional operator. So we have to work our way in, which means before we can get here, we've got to do this disjunction, do this conjunction here. But before we get to the conjunction, we have to do the disjunction and this conditional. Ultimately, it doesn't matter which way we start, so let's just start here at the beginning. Remember, the rule for a disjunction is that only one of them has to be true in order for it to be true. If they're both false, it's false. So in this case here, and I'll change my color to blue. Maybe that'll help out, help you see the difference. So we've got true, 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 false, right? And then I'm gonna do this one where the conditional. Remember, the conditional rule is if the antecedent is true and the consequent is false, then it's false. So this one's false. So it's true, 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 right? Now, what I need to do is I need to compare these two columns, in this case the blue columns, and utilizing the conjunction rule. I'll change to the color red for the conjunction. Now remember, what's the rule for the conjunction? Is that both of these have to be true. If there's any falsehood, it's false. So the conjunction rule is the strictest. So this is true, true, false, false. Okay? And now I can utilize this line and compare it with this B line over here. So I'm comparing these two things utilizing this conditional rule right here. And so let's switch to green. And so in this case, remember the conditional rule is the same as this one. So this is true, false, right? Because you have a true antecedent and a false consequent. This is true, and this is true. So this ultimately is the final line under the main operator for evaluating the truth functionality of the entire proposition. A or B and B therefore A therefore B, right? That whole proposition's truth functionality is determined, or all the truth possibilities, we might say, are in this column over here. Okay, so then the question is, once we establish what the truth possibilities are for a proposition, there are different ways in which we can classify a statement. So I want to give these for you, right? In terms of classifying statements. Right. In terms of classifying statements, there's essentially three things you need to know. There's three classifications. The first is a tautology. A tautology in which they're all true, right? In which, in this case, right, if you go back to this one, this is not a tautology, but if each of these were true, if this second line was true, we would have a tautology. And what a tautology means is that it's true by necessity. It has to be true. Interestingly enough, in philosophy, tautologies are fairly worthless. Because if something is just always true by necessity, then it's not really that interesting because it doesn't really tell you about anything. But that's a tautology. The second here is self-contradictory, or you might say contradiction. And that's just the opposite, in which they're all false, right? So self-contradiction would be if all of these truth values ended up being false, then we would say that it's a contradiction. The majority of statements are neither tautologies nor are they self-contradictions, but they're actually what we call contingent propositions. And to be a contingent proposition, you essentially need one value that's true and one value that's false, right? Where essentially you have both values possible. Right, you have true and false. So if we go back to our earlier proposition here, this proposition is actually a contingent proposition because in order for it to be true, certain conditions have to be met, and hence the truth value itself is contingent upon whether or not those conditions are met. So that's the way in which we can sort of classify statements. Fairly simple at this point, right? They're either all true, they're all false, or at least one is true and at least one is false. And so that would be contingent. So that's classifying statements. And I'll give you a few of those examples real fast. Let me just give you one, because if you take a look at your book, if you're in my class or if you're watching this on YouTube, we're using the Hurley book edition 10, a concise introduction to logic. If you're using that book, you can look on page 317, in which they sort of show you examples of each of these. I'll give you one example here, but I don't want to give you too many because we don't have too much time to do that. So let's see here. We can say if you have G, then you have H, right? And G, oops, sorry, it's hard to read. Therefore H, right? So this phrase will actually turn out to be tautological, right? So let's just show you real fast. You have true, true, false, false. And the more you get to do this, I think the faster you'll see. It's actually fairly easy. Where most people by far make mistakes is they just aren't consistent and neat about what they do. Now, I realize that in my video here, my handwriting's not neat, but that's partially because I'm writing on a tablet. But if you want to do well in these, you really have to be neat in what you do. So this is going to be true, this is going to be false, true, true. Now I utilize this line and this line using this rule. And so this is going to be true, false, 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 right? Now I utilize this line. If you're using just a pen, you don't have to use colors. You can just sort of circle the two so you get a sense of it. Ugh, I'm horrible. So this is true, and true is true, 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 true. And then ultimately you can see here, in every possible condition, even if both G and H are false, this proposition is actually true. So this is this means that this is a tautological proposition. That's how we would classify it going back to over here. Our tautologies are all true, our self-contradictions are all false, and our contingents are both, where we have both values present. Okay, so then the next question is, what happens when we take two different propositions and compare those? I'll be doing that in my next video on comparing statements. Okay? Talk to you soon.